So this is one of the most important lecture in rotational motion. So please all of you write it. Moment of inertia of rod, disc, ring, and as well as cylinder, and we can say triangular lamina. So we are going to find the moment of inertia of these things. We are going to find the formula for what is the moment of inertia of rod, disc, ring, and all. So mostly one or two will solve, mostly three at least will try to solve in our today's class. So let us come to now here. First, let us understand. So this moment of inertia for continuous bodies. So last class we have studied introduction of moment of inertia, and we have solved many sums also. So now this moment of inertia, we are going to study for what kind of bodies? We are going to study for continuous bodies. So now let me take in last class, we have derived the formula. Moment of inertia is equals to, what is that? Different particles are present in different distances. So sum of the masses or momentum of the individual particles, if you add it, so that is only is equals to total momentum of the system. Am I right or wrong, everybody? So you can take it as a n number of particles. So that is what we used to call as moment of inertia. So now let me take some random body. You can take it a random body, and axis of rotation is passing across this point. This is what axis of rotation. So from the axis of rotation, let me take this particular particle. See, total mass is capital M. Let me take it. Now, particular mass means what we can say, guys, differentiating. So particular mass of this particular part, I will take it as a dm. What is that? Mass of the particular part is what? Dm. And let me take that from the axis of rotation, the distance is r1. Let me take it. Or some other particle I will take in some other distance, who is this particle mass is also dm, and it is r distance. Or some other particle distance I will take it, who is presented, again the mass of the particle is dm, and is presented r2. This is r1, and that one is r2. So like this individual particular particle I am taking. Now if I want to find the total mass, so what will happen, guys? What will do? So for example, here I will write it. So from this I will say, what is the total momentum of this body? So total momentum, moment of inertia if I want to find it. So what do I have to do it? So particular part, if I take it for example, so what will happen? If mass is dm means, then moment of inertia also will become what? Everybody, di understanding, which is equals to dm into r square. Is it okay? Rudresh, for understanding? So this is the my, moment of inertia for what particle? Total mass or small particle? Everybody. It is for
Small particle.
small particle. Now, if I want to find the total momentum, so what we'll do? A particular small particle, we will make it dm into r square. So now if I want to find the total momentum, we have to use some mathematical operation. What is that, everybody? Yes, please. Total, we have to find it. So that we have to apply what concept? Integration. So integration of dm is equals to integration of dm into r square. So integration of integration of dx is what? X. So integration of di is what? I. So the total moment of inertia is equals to integration of dm into r square. So this is the formula for finding the total momentum of a continuous bodies, motion, the bodies which are in continuous. So this is what the total momentum is equals to integration of dm into what? Everybody, dm into r square. Understanding all of you? So, clear, everybody? So now we are going to find moment of inertia of a uniform rod along the axis passing through its COM. What do you mean by COM, everybody? Yes, please. COM means what? All of you. Center of. So find the MOI, moment of inertia of a uniform rod. First one we are going to find. So uniform rod along the axis, passing through its COM, center of mass. Clear, Rudreswa? Now, let me take some rod. So for our purpose, so just I am drawing. 1 minute. So I'm taking just like a boxes so that it is easy for imagining light. So it is uniform rod, means mass is distributed uniformly or not? Everybody? All of you?
Yes, sir.
Yes. So mass is distributed uniformly. Just imagine it is a rod I'm just taking. So you can take it into many things. Like let me make it smaller, so that it is easy for us to make it. So this is the uniform rod I am taking. Clear? Understand everybody? Yes. So let me consider this is a uniform rod. Now exactly in the middle axis of rotation, through the center of mass axis of rotation is passing. So let me take this is the center of mass. Everybody verify it. Is it correctly matching? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Is it okay, Pradosh? So this is what is axis of rotation. And I'm just taking. So axis of rotation is this one. Is it okay, Please respond, guys.
Yes,
All
sir.
of you?
Yes, sir.
Yeah. Now the total length of the rod. Let me take the total mass of the rod is M and the total length of the rod is L. So mass is distributed. How? It is
Uniform.
uniform rod. So mass distributed how, guys? Mass
Evenly.
distributed evenly. So uniformly. That is what it is. Okay, everybody. Now let me consider this is the total length. Understanding total length and total mass is M and L. We have been considered. Now let me consider particular part alone, brothers. So just observe. I will choose this particular path alone. I will shade it. Now this mass of this particular part, how much it will become, everybody? Mass of this particular part. Let me assume how much it is. Dm.
DM.
You understanding? So from the center of mass, it has been present at a distance of x meters. X centimeters or meters. Are you clear what I'm saying, everybody? All of you understanding? So this is the center of mass. So it is present x meters. Or else this side also I can take, which is present from the center of mass. So again, this particle also I can take it. So what is the mass of this particle? This is also all of you.
DM.
Dm, and it is also present x meters. If I take this particle, for example, so which is present in some other distance from the center of mass. So let me take this particle as also m, so which is present at some, let me take x1 distance. And if I take this side, it is another particle if I'm taking, so which is also present at some x1 distance. So now this r is remains constant or varies, everybody? Remains? Varies.
Constant.
Constant. If I take different particles, definitely this distance from the center of mass is not equal. Am I right or wrong? Everybody? Yes, Mr. Rudreswa? So
Yes.
that is what. So actually, it is a uniform rod and along the axis passing through the center of mass. So all of you observe the total length of the rod. I will take it as a what? Everybody? Total length of the rod what? L. Okay. Now exactly center of mass, if I take like a mathematical rule in scale, all of you observe, just you consider. Now first particularly this particle alone I am considering. Now what is the moment of that particular particle? Anybody can tell me? Moment of that particular particle. This particle alone you consider. All of you should tell. Moment of this particular particle alone. Tell me guys, dm is equals to, yeah, di is equals to dm into r square we know. But here r is equals to what we have taken? All of you. R is equals to what? X. So means in the sense of, it will become what, Pradosh? Di is equals to, yes, please. Dm into x square. Now I want to find the total momentum of every particle. Maybe this particle or this particle or this particle or every particle. So that what is the concept we have to apply it? Differentiation. So integration. Integration of di and integration of dm into what, everybody? Dm into, yes, please. X square. Now, all of you observe. I will choose this side particle from the x distance, and this side also if I choose from the x distance, then this both the particles from the same distance from the x, so from the center of mass. Will you all agree with me, everybody? Yes, please respond, all of you. Any doubt, please ask. Understand? If I choose this particle, this distance and this distance is both are same. Am I right, Rudreswa? Yes. So if I consider the midpoint is 0, now this length will become what? This total length will become what? Everybody. This total length will become what? L by 2. And this total length will become what? Anybody? So it is opposite direction. 0 this side positive and this side what will become? All of you. Minus L by 2. So the total length, what is the total length of the rod? Everybody. Total length of the rod is how much? L. So now exactly if I take it middle, so this side it is L by 2 and this side is also it is a what actually? L by 2. But this side positive and this side is what? Everybody? Negative. Limits. I am finding the limits. Nothing is there. Now forget about this L by 2 and sorry minus L by 2. Now you just tell me. So if I choose this side and this side, what is the limits? For example, exactly from the middle, I am choosing it. So what is the limits for this one? 0 to. What is the limits for this? For example, I choose this particle. So what is the limit? Anybody? Apply the limits and tell me. So how much it is? So integration of di, which is equals to, what are the limits, Ram? Rudraswa? Only half I take. What are the limits? 0 to L by 2 into dm into x square. If I say, for example, both the sides, if I take two sides, so it is a uniform rod and mass is distributed uniformly, so that this whole term will become twice. That is what is the meaning of it's the whole rod. That is what L by 2 plus L by 2, which is equals to L. Am I right or wrong? Everybody? Yes, please. So if it is only one side, one half, it is integration of 0 to L by 2 into dm into x square. But if I consider two sides into 2, if I do it, so that it will be modified into what? Roots, limits you tell me now. So integration of di is I. So now roots will change from where to where? If it is only half rod means it is varies from 0 to L by 2. If it is now two sides, both the sides means then limits will varies from where to where, guys? Please respond. Minus L by 2 to L by 2. So the limits is from minus L by 2 to L by 2 into dm into x square. So this is what the total momentum. Total momentum. Do you understand all of you? Please respond. The total momentum of a rod is integration of limit minus L by 2 to L by 2 into dm into x square. Now, let me consider this rod is one dimensional. It is exactly kept on a plane. So that I'll consider as a what, guys? One dimensional one. Understanding rod is always considered is a one dimensional one. So if I take, let me take, I will introduce a new word. All of you observe, which is called as lambda. So lambda is actually means in the sense of mass per unit length. What do you mean by lambda? Everybody? Mass per unit. Please respond. Mass per unit length. Now, from the center of mass, if I take, for example, 1 meter distance, can you tell me, Mr. Rudreswar, what is the mass of that particular length? Mass per unit length, I am saying. If I take 1 meter length, what is the mass of that? Anybody? Mass is how much? Pradosh? Mass is lambda. Do you understand it? Mass. Lambda means mass per unit length. Unit means 1. So if I take 1 meter length, then what is the mass? Everybody, please respond. Lambda. If I take 2 meters length, if I take 2 meters length, it will become what? Mass will become 2 lambda. If I take 3 meter length, please respond. If I take 3 meter length, then lambda will become 3 lambda. 3 lambda. Understanding? So this is mass. Mani and Samya, are you understanding? Mr. Rudreswa, Pradosh, Narayan? Yes, sir. Anything doubt you can ask. Now, same way, I am taken 2 meters length. It is lambda is a mass. 1 meter length lambda, 2 meter length 2 lambda, 3 meter length 3 lambda. Now I am taking in a rod. I am taking a very small length. Suppose this is what. So I have taken as a dx length. So then you tell me, what is the mass of that? Anybody can tell me? I have taken a dx of x. Dx length I have taken. Then, anybody? Dx length I have taken. What is the mass of it? Please speak. If it is 3 meters means 3 lambda. Now dx means what is that? Everybody. Dx lambda. What is that, everybody? Please respond. So dx length. If I take dx length means what is the mass of that? Everybody. Please respond. Dx into lambda. So that is what it is. You have to remember. Very important one. One dimensional mass per unit length. Two dimensional means mass per what will come? Everybody. Mass per unit area. Three dimensional means mass per unit volume. Unit volume. Okay. So of course we'll study that. You forgot about it. Now one dimensional means what is that? Mass per unit. Everybody. Mass per unit. Respond.
Length.
Mass per unit length. Clear?
Length.
Now, in a rod, particularly, I chosen a particular part. What is the mass of that particular part, everybody? What is the mass of the particular part? Please respond. dm. Understanding?
dm.
I choose a particular part now whose mass is dm. All of you observe very carefully. Whose mass is dm and what is the length? Anybody can tell me? The length is x. The dx are normal x dx and mass is dm. So if it is mass is dm means, can you tell me what is that? Dm means will become what? Dm is equals to mass of mass is dm. So can you tell me what is the length of that one? Anybody? If the mass of this one is dm means, what about the length? Length will become what? Everybody? dx into lambda. So that is what it is. All of you understand what I'm saying? So the mass of this particular particle is dm. So means if I've taken, so dm means the mass of that particular particle is equals to dx into lambda. That is what? Length. Dx into lambda. Lambda means mass of that one. So that is only called as dm. Dm means the dx into lambda, mass of that particular particle is only dm. So we have written the formula. I is equals to, we have got it. What is the limits? Minus L by 2 to L by 2. So instead of dm, what I can write, guys? Everybody. Instead of dm, what I can write? All of you respond. dx into lambda into x square. Now, can you tell me mass per unit length? It is always remains constant or not? It is mass is uniformly distributed. So mass is remains constant or not? Lambda. It is uniformly distributed. So lambda is remains constant or not? Speak, guys. Everybody. So lambda is remains constant. So lambda will take off out. So limits is minus L by 2 to L by 2. So x square dx. So this is what is what? So moment of inertia is equals to lambda into integration of x square. You all should tell me. Integration of x square. What is the formula? X cube by 3. Understanding? From limits minus L by 2 to L by 2. Now, what is lambda formula? Can you tell me what do you mean by lambda? Lambda means what, guys? Mass per
Unit length.
what? Unit length means m by L. So lambda means mass per unit length. So which is equals to m by L into limits you substitute. What will happen? L by 2 whole cube. L by 2 whole cube divided by 3 minus of minus L by 3 whole cube divided by 3. Am I right? Everybody, will you all agree with me? Please speak. So which is equals to m by L into L cube divided by, this is what, everybody? 3 square. So 3 cube. So 3 cube only, yeah. Yeah, L by 2, sorry. L by 2, 2 square. So 2 square means what, guys? 2 square means what? 4. Sorry, 2 cube, 8. And 3 will come up. It will become what? L cube by, respond. L cube by 24. 3 will come. 2 cube is 8. Next, minus of minus, because it is odd number. So again, minus will come up, plus will come up. Let me put again. So it will become minus L cube divided by 24. Is it okay, everybody? So minus of minus will be plus. So m into L. So L cube divided by 24 plus L cube divided by 24. So if I multiply this two, I'll get it, sorry, addition. So m into m divided by L divide into L plus L, how much it is? 2L cube. Correct?
2L.
Yes. So 2L cube
Yes.
divided by 24. So 2 ones are, 2 12s are, and L and L cube will get cancelled. So what is the formula? Everybody? ML square by 12. So this is the moment of inertia of a rod. So formula, if you want to find the moment of inertia of a rod, this is the formula which you have to use it. So this is what is about the derivation of moment of inertia. I hope you all understand. Anybody having any doubt, you can ask me. So please proceed. Are you clear, everybody? All of you? So DI, so this particular part I am selecting and I am applying the integration to find, because mass is distributed uniformly. So and then I am proceeding. Are you clear, everyone? Please respond, guys.
Yes, sir.
So please do it. See here, we have written that the mass of the dx particle. What is the mass of the dx particle, everybody? Mass of the dx particle is dx into lambda. So the dx means that is only we are considering as a dm. Am I right or wrong, everybody? That length only, dx is only we are considering as a dm. So that is why the mass of this dm is equals to what? Dx into lambda. Do you understand, Ira? Rudreswar, clear? Yes?
sir.
So that is what it is. So if you understand that, so slowly derive, you'll get the answer. ml square by 12. So anybody having any doubt, you can ask me, or else you can proceed. Are you clear, everybody? Girls, all of you, Mr. Narayan, anything doubt, ask me. Clear?
Yes, sir.
Yeah. You should be able to understand and you have to make it, see, concepts are very, very clear. It's not easy at all. 11th is not like 12th, I'm saying you correct. Remember, entire 10th class is equals to this chapter. Entire 10th class physics is equals to this one chapter. Not even equal, I'm saying. Just I'm saying how much you struggle to learn all the 4 chapters of class 10 physics, which is equals to rotational dynamics. By this time, you might be understand. See, the classes which I am taking is not for your school exam. I think by this time you might be experienced it. Am I right, Mr. Rudreswar? So many new things you might be finding which is not all it is. Even your school, they will never ask even what is the particular level. So we are going for NEET and JEE level only, we are preparing. Even first year for me, how much I am struggling to prepare, I only knows. So you should all able to show interest. That is what expecting from you all. You are all committed and you are my first batch of 11. How much you have to work? You have to bring good name for me always. That is the reason I always will shout on you or scold on you, because my expectations are very high. You have to satisfy your parents. Many people are believing me. You should be able to understand what is the situation is happening. Okay. So shall we start now? Question related to this. Anybody having doubt, you can ask me. All of you? Will understand, Amma? Clear,
Yes.
Asmita? Salda? Everybody? So rod.
Yes, sir.
What is the moment of inertia of a rod? Everybody? So I is equals to ml square by 12. If it is when the center of the axis of rotation is passing along the what? Everybody? Axis of rotation is passing along the
Center of
Center of mass.
that is what. Now, take next question, everybody. So calculate the my of a uniform rod. So rod is the one-dimensional one. So uniform rod along the axis, passing through one end of the rod. One end of the rod, who is having mass is m and length is what? Total mass is m and length is how much, guys? L. Clear, everybody? Yes. So let me take now axis of rotation, and see that uniform rod along the axis passing through the not center of mass COM. It is passing where? Everybody? Yes, please respond.
One end.
One end means in the sense of rod is present. So let me take it. I will take rod. So why we should be? So I will draw the rod and let me consider this is the rod and the axis of rotation is passing where? Not center. So where it is passing, guys? It is passing at the one end. So this is what I am considering axis of rotation. Anybody having any doubt, you can ask me, or else we'll proceed. So this is the axis of rotation. Any problem for anybody? All of you? Clear? So axis of rotation, let me take now x and x. So we have to find it, what is the moment of inertia of a uniform rod along this axis of rotation. Clear? So now, if I consider axis of rotation, now let me consider again a particular particle. So what is the mass of this particular particle? Any particle I can take, either this particle or this particle or whatever the particle which is present from some x distance. So I'm taking this length of this one, I will consider as a what, everybody? I will consider as a dx, and mass of this particular part is what, everybody?
dm.
So any particle I can take, your choice. So you can take it. So which is present at some distance, okay? Some distance from the axis of rotation. Now let me take Okay. So now this is the beginning point, this one. So can you tell me x is equals to what here, rod? X will become what? Yes, please. 0. And at the last point, Rudreswar, what is that x equals? For example, I take the point here. X will become what? X will become what? Please respond. X will become
L.
L.
So now option A, please make sure ml square by 6. Option B, ml square by 3. Option C, ml square by 4. And option D, ml square by 8. Let me see who will solve first. Solve it. I'm just giving 30 seconds time. If you find it, you can. If not, I will teach. Make sure you have to try. Everybody has to try. Own. Put something and try. That is what is my expectation. All of you. Are you clear, everybody? Please respond. All of you. Anybody able to find it? Answer, Ra. Answer, please. Rudreswar. At least tell me, guys, what you have tried or not. Hey, you don't know. Limits is starting from 0 to L. What else is there? You can apply the formula. So particular particle I am taking this much time or Rudreswar. What else is there? First question itself, don't expect after 100 questions I will be fast. You have to solve at the beginning itself. What will happen? What is there in that question? So di is equals to integration of dm into x squared. So now we all people know limits. So integration of di is I. So limits is from where to where? 0 to L or L by 2 to L by 2? 0 to L. Because before rod, the axis of rotation is passing from where? Along the center of mass. Now the axis of rotation is from along the one of the end. One of the end means here x is equals to 0. At the last, x is equals to L. So what is the limits, guys? X equals to 0 to L. That's all is there. So dm into x square. So you all people knows that. Just now we studied that. So lambda means mass per unit length, If it is 1 meter length, lambda is the mass. If it is 2 meter length, 2 lambda is mass. If it is dx meter, then dx lambda is the mass. So we all people knows that if I choose a particular mass, understanding who is having a dm and having a dx, then the dm is equals to dx into lambda. That's all. You cannot do that. So replace it and you can do limits is 0 to L, lambda into dx into x square. So lambda always remains what? We all know lambda is what remains because uniformly distributed. Uniformly distributed means it is constant. So lambda will be outside, which is equals to 0 to L x square into dx. So integration of x square dx. What is that? Lambda I will replace with the m by L. So x square dx. So which is equals to m by L. Then integration x cube divided by 3 into 0 to L. 0 to L. That's all. So substitute it. What will happen? Everybody. So which is equals to m by L into here in place of x cube I will substitute L. So it will turns into L by 3 minus 0 means 0 only. 0 cube divided by 3. So which is equals to ml, m m by L into L cube by 3. So cube and L